We're solving problem 14 from the 2025 AIME2. The problem reads, let triangle ABC be a right triangle with angle A equals 90 degrees and BC is 38. There exist points K and L inside the triangle such AK equals AL equals BK equals CL equals KL equals 14. The area of the quadrilateral BKLC can be expressed as n root 3 for some positive integer n. Find n. The first thing we can do is draw out the triangle ACB. We know that angle A has to be 90 degrees, and we let points L and K, they have to be equal distance. They have to satisfy basically all of these. So basically, now that we've drawn it out, we can see that it might be hard to see if you draw it out because it'd be hard to, but by using these properties, we can see that this triangle KAL, is equilateral, meaning each angle is 60 degrees and each side is of equal length, and two of these triangles, AKB and ALC, are isosceles, meaning that these two angles are equal. So the main insight for this problem is you basically do all this angle chasing, right, to find eventually the desired area. So you want to find a desired angle that will greatly help us solve this problem. So what we can see or observe is that if we have, let's just let angle AKB be 2 times theta. This makes it a lot simpler. If it's 2 times an angle of theta, then that means angle K, that means angle KBA must be measured in 90 minus theta degrees. We know that, again, I'm just going to write it again, but angle KAL is 60 degrees. So we also know that this one is 90 minus theta. So 90 minus theta plus 60 degrees, you're going to find this angle. So we find that angle LAC is equal to theta minus 60 degrees. So theta obviously has to be greater than 60 for this to be possible. We know that LAC is theta minus 60. So we have this property right here. And what we can notice is that we also have an angle of angle ALC, which is 300 degrees minus 2 theta, the angle right here. Therefore, we have angle KLC being simply 2 theta degrees. Therefore, we know that this angle, if we draw a line from C to K, this angle is 2 theta. So we have these triangles are equal. They are congruent because they have these properties. They have congruent angles. So what we can now do is we can rotate the said triangle around this point, the center of KAL, such that it forms a triangle BCD, where basically BCD is made up of 3 quadrilaterals and the inside of triangle KAL. We know that these quadrilaterals, the 3 smaller quadrilaterals, are equal to the area of BKLC. So what we do is we've basically just formed a larger shape to deal with. So if that's true, we formed a larger shape. We know that the area BKLC, well, we have to see that this is the whole area of the new triangle BCD, and then you subtract the inner triangle KAL. That leaves us with the area of the three smaller quadrilaterals that each one is equal to the area of quadrilateral BKLC. Therefore, to find the area of one of the quadrilaterals, we have to divide by 3. If we divide by 3, we can start solving, and this gives us 361 root 3 minus 49 root 3 over 3 using what we are given. Therefore, our answer is going to be 104 root 3. So we are asked to find positive integer n. We see there's a root 3 and there's a 104. Now, I didn't say this earlier, but triangle BCD is also equilateral with a side length of 38, meaning that each side is 38 and each angle measure is 60 degrees. So 104 is our answer for this problem.